Hey. Sound check, sound check, sound check. Madungog ra ko, class? Madungog ra pogi. Ito, good day everyone. Mayong adlaw ka ninyong tanan, especially to you, Miss. By the way, we are the group 8 and I am Gilvin Ersan Guanzon, your first Pugi reporter for this day. So our group will tackle about concrete pavement. But before moving on, or before we will go to the second slide, I would like to ask if what comes into your mind when you hear the words concrete pavement. So obviously, kung makadungog tag word nga concrete mo ra siya kanang humok nga mugahi. Sakto ba? Humok nga mugahi. Mao na siya. Ug mo na sa tag pavement mo ra siya, it includes mo ra siya mga karsada or gahi nga surface sa road or sidewalk, mga ana siya. So actually ga-search ko siya. Ga-search ko about concrete pavement ug naa ko'y na-search. So next slide please. So mao ni siya. Concrete pavement. A concrete layer that is in contact with traffics directly, and it is used for different purposes and application. Also known as rigid pavement. So, to add, concrete pavements are used for general paving needs such as driveways, parking lots, and playground. So, next slide, please. So, we have here the subtopics. First, Portland cement. Portland cement. Combination of limestone, marbles, or other calcareous materials and clay, shale, or like argillaceous substances. So natay mga different types of Portland cement specified by AASH2. AASH2 means American Association of State Highway and Transportation Officials. So first type 1 or 1A, air in training. For general concrete construction, when the specified properties of the other four types are not required. The second type 2 or 2A, still are in training. For general concrete construction exposed to moderate action or where moderate heat of hydration is required. Third, type 3 or 3A, for high strength concrete. Type 4 for low heat of hydration, and type 5 for high sulfate resistance. Next slide please. So we have here a table, the composition and strength characteristics of various types of Portland cement. So kani siya nga table, makita ra ni sa amo ang PDF. Pwede rin ninyo siya okay yun dito or para familiarize jud ninyo og tarong ang table. So we have your types of cement, compound percent, strength normal, Portland cement concrete percent, mga days, months. Inyo na lang i-check dito sa akong PDF para mas clear jud or mas ma-familiarize jud ninyo. So nasa tayo notes diri nga ang Portland cement constitute the following chemicals. We have here tricalcium silicate, dicalcium silicate, tricalcium aluminate, tetracalcium alumina ferrite. Next slide please. So now we will move to the concrete pavement characteristics and behavior. First, the behavior of concrete pavement that is exposed to loading and environmental effect entirely depends upon the quality of concrete, the underlying subgrade, and the base course. Generally, concrete is strong in resisting compression load acting on it, but considerably weak in resisting tensile stresses. The reaction and the movement of the subgrade supporting the slab affects the stability of the concrete pavement. Concrete, like other materials, also expand and contract due to temperature changes. It expands when wet and contracts when dried. After pouring, concrete shrinks as the mortar hardens, the cement hydrates. concrete pavement changes in length with time of day for being exposed to different elements of weather changes. A curl tendency is very likely due to the effect of daily and seasonal temperature and moisture differences between the top and bottom of the slab. So next slide please. Concrete pavement design assumes the following considerations. Number 1, that the pavement slab was designed as plain concrete beams. Number 2, that transverse cracks on the concrete pavement cannot be avoided. The designer, however, presumes that the pavement cracks could be controlled by providing reinforcements to the slab joints with the following assumptions. So naani siya yung mga sub-statements diri A. With reinforcements, cracks on the slab will be combined to a weakened plane joint space at 4.50 to 6.00 meters distance. Vertical offsetting across the narrow cracks will be prevented by aggregate interlock or by dowel bars. Third, with simply reinforced slab, cracks will only appear at weakened plane joint space at 12 to 20 meters intervals. Hair cracks to be held tightly by the steel between joints. With continuous reinforcement, transverse joints are omitted. Hair cracks are checked by the steel and develop at close intervals. Faulting is countered by aggregate interlock and steel bars. So now, the third one. The longitudinal cracks on the pavement slab more than one lane wide is inevitable. Fourth, pavement slab is supported by foundation that deflects when loaded but recover when the load is removed, assuming that the foundation materials are elastic or like a dense liquid. Sorry guys, ako magsaba kay ngiro sa mga wala. Sinsyae lang niya, sinsyae lang. Padung gram gihapon ang kanindot sa kontingog bisag na isaba ang aero. So padayon gihapon ta. Tingog ra na sa aero. Wala ra nay kuan sa kagwapo sa kontingog. Padayon gihapon ta. So now we have here control of cracks. Load transfer and anti-joint alignment is sometimes dependent solely on aggregate interlocking. If the joint opening is considerably small from 0.03 to 0.04 inch, the projecting aggregate is considered tightly keyed, and when the edge of one slab deflects due to load, the adjoining edge will also be forced down. So kabawa na mo, sa rason na. No, forced down. So now, if the coarse aggregates are weak, as when the joints open so wide, the aggregate interlock is considered ineffective as a means of load transfer. Dowels can be painted, greased, or coated with asphalt for almost one half of their length to break the band with concrete, allowing the dowels to slip within one of the abutting slab ends. Okay, next slide please. So now we have here the transverse expansion joints. Expansion joints provide space allowance for the lengthening of slab due to expansion. So we have here another table. Naanaputay table. Kani nga table recommended dimensions of dowels for concrete pavement joints. You have here pavement thickness in centimeters, dowel diameter in millimeters, dowel length in meter, dowel spacing in meter. Source to Interior Guide and Proposed Revision 1980. Makita gyapon ni sa among PDF guys. Pwede rin ninyo kayo namang PDF or pwede ra pa magbalik-balik kung tanaw sa video niya inyo yung i-post. Automatic na guys. Makita ni kagwapo sa mong table na magic ba? So now, let's proceed to the basic type of concrete pavement joints. So naata diri upat ni siya, upat contraction joint, expansion joint, longitudinal joint ug construction joint. So actually naa diri maayo kuha na ko kauban or ka-group nako nga naa siya i-discuss sa kaning upat. But this time, muhatag ko mga gamay lang gud nga explanation or meaning sa kaning basic type of concrete pavement joints. At least naasad mo idea ba? Sakto ba? Right? So first, we have here construction joint. A sewed, formed, or tooled groove in a concrete slab that creates a weakened vertical plane. Next, expansion joint. An assembly designed to hold parts together while safely absorbing temperature-induced expansion and contraction of building materials and vibration, or to allow movement due to ground settlement or seismic activity. Third, the longitudinal joint. Constructed when one lane of HMA mo siya ang hot mix at asphalt. Hot mix asphalt is paved. Then the adjacent lane is paved next to this now called joint. Okay. Next, construction joint. The interface between concrete placements intentionally created to facilitate construction. So next slide please. So this time I will be explaining to you more about longitudinal joints. So mao ni siya. Longitudinal joints provided between adjacent traffic lanes. It is considered as hinge to provide edge support but allows rotation between the slabs. By this joint, flexural stresses that might cause irregular cracks along the length of the road are relieved or neutralized. So naata diri, longitudinal joints cannot be considered as a major problem under the following assumptions. So naata diri ay mga following assumptions. Naata diri unom kabuok. So first, that there is no big load transfer across it. Okay. Second, that the expansion and contraction movement developed across the pavement width is very small. Very small. Third, when lanes are constructed at different time using side forms, the joints are provided with K-way in the first slab to accept load transfer. Fourth, for longitudinal joint, deformed tie bars are used because the purpose is to hold the slabs tightly together rather to allow the joints to open and close. Fifth, the diameter and spacing of tie bars are based on the force needed to pull the narrow pavement slab over the subgrade to the joint. Last, the length of tie bar is determined from the embedment inside the concrete necessary to develop the strength of the bar. So kanang uno mo na ang siyang following assumptions. Longitudinal joints cannot be considered as a major problem under the following assumptions. So now, moving on to the 10th slide, we have here the recommended tie bars for longitudinal joints in concrete pavement 3.60 m lane width. So naa na mo tay table guys. Gwapo kayo na to ang PDF. Gwapo sa kayong report. Gwapo tanan. Basta mo sunod yung report. Gwapo sa to. Naa pa dyan tayo gwapa ang reporter ng taon pa dyan. Gwapa sa to siya. Tagalog na siya guys ha. So karon 10 slide na sa tay table. So kanya tong table ato na po makita so PDF pwede ra po na inyo tanan maminaw na ko tarong or ubasa sa mong inyo ha. Pwede ra na maminaw mo na og tarong mabasa sa mga inyo ha o matik i-exam na perfect ang tanan. So mao ni siyang 10 slide recommended tie bars for longitudinal joints in concrete pavement 3.60 m lane width whether type and grade steel working stress PSI pavement thickness in cm 1/2 which is diameter bar 5/8 bar system bar diameter na ato tan-awan na diha. Ato ni ato yan ano to makita nila guys. So thank you guys sa kay inyo jud kong giubanan sa akong pag-report karon og namina jud magtarong ka ba akong namina magtarong guys kay pugi ba yung nag-report. Salamat kaayo og ako na niyatag. So now I will give the floor to our next reporter, Mr. Kiamko. Mr. Kiamko. So thank you guys.
Thank you, Mr. Gonzon, and hello everyone. I am Rashid Kaiser O. Kiamko. I am going to discuss first about construction joint. So, what is construction joint? Construction joint is the interface between concrete placement intentionally to create construction. If concrete pouring will be interrupted for quite some time, that cold joint will be inevitable. This practice is to provide transverse construction joints. Deformed tie bars are used to hold the joint tightly closed together. However, if the construction joint replaces a contraction joint, the use of dowels is alternative. Construction joints and cracks should be cleaned and sealed to prevent infiltration of water to subgrade and keep dirt out of the joints. So now, let's move on already to reinforce of joints. So, steel reinforcement for concrete pavement joints are specified in the design to prevent the widening of cracks produced by shrinkage or thermal contraction. So, the reinforcement holds the fractured faces in rigid contact, preserving the aggregate, interlock, and intrusion of dirt or water. This reinforcing bars, however, is not intended to resist frictional stress being produced by loads or curling. So, this topic no, di lang kayo ta mo dig down ani kay more on calculation naman siya. So, mo proceed na lang ta sa next one. So, let's move on already to the subgrade and subbase for concrete pavement. The construction standard for subgrade and embankment are precise and almost typical for all pavement types. Under the concrete pavement literature, the undercourse or selected material is always imposed upon between the subgrade and embankment of the concrete slab. The AASHTO recommends that the subbase must be extended from 30 to 60 cm outside the pavement edge to serve as an edge support. Treated cement asphalt is recommended for the heaviest travel facility because it increases the fatigue life and reduces joint failures. The wide acceptance of stabilizing the subbase with Portland cement concrete pavement is due to investigation result of pumping of concrete slab. Talking about this pumping is all about the ejection of water and subgrade soil through the joints and cracks along the edges of the concrete pavement. So let's move on already to concrete proportions. In concrete proportions, we have fundamental rules to follow so that we can obtain a good concrete. So the first one is type 1 or 2 cement is specified for concrete pavement. Number 2, water for concrete must be clean, free from acids, alkali, and oil. Water that is suited for drinking purposes is acceptable for mixing cement except water containing large amount of sulfate. Number 3, if concrete is to be strong, sound, and durable, the aggregates must be similar properties. Number 4, the mineral aggregate of concrete is about 75% of the volume of the 80% of weight of normal pavement. Number 5, the maximum size of coarse aggregate is 2 inches. However, the use of larger aggregates, according to some experienced highway engineers, increases its length and durability. This precept is supported by reasons that with no larger aggregates, less water is needed, thereby increasing the ratio of cement water. Under the cement water ratio principle, concrete is stronger when water content is less. So let's move on to admixture. Admixture is a substance added in mixing to change the characteristic of a concrete mixture. There are varieties of admixtures available like air entraining admixture, which is very common. Others like water reducer, retarder, accelerator, pozzolan, and plasticizer are also used. So the next one is air entrainment. Air entrainment is the entrapment of air in the concrete mixture in the form of evenly distributed small bubbles. It is used to increase the concrete resistance to surface scaling caused by de-icing with calcium or sodium chloride. Another working advantage of an air entrainment is improving its workability and reduces bleeding in fresh concrete. The effectiveness of air entrainment is to increase the concrete durability that is influenced by number 1, percentage of air present in the mixture, number 2, grading of aggregates, number 3, size and distribution of air bubbles. Air entrainment in concrete may be attained by using air entraining Portland cement or by air entraining admixture added to each batch for concrete while mixing. So, okay, let's move on already to the cement water ratio. So, as we mentioned earlier, the strength of the other desirable properties of concrete mixture varies depending upon the ratio of concrete to mixing water. So, a non-air entrained concrete with a water cement ratio by weight of 5 gallons of water per bag may have compressive strength about 5,300 psi in 28 days. So, on the other hand, a mixture of concrete with 7 gallons of water per bag of cement has developed strength of 3,700 psi for only 28 days. So, therefore, its durability is dependent always on the water cement ratio that should be properly controlled to obtain richness of the paste. Then AASHTO guide specifications for highway construction establish the maximum water cement ratio at 6 gallons per bag of cement on normal conditions of 5.5 gallons per bag of cement for severe atmospheric conditions. So let's move on already to my last topic, which is the concrete mixture. Considering the high cost of the cement, the objective in mixing concrete is to use more aggregates and as little cement as possible while maintaining the workability necessary for successful pouring and consolidation. So we have ways here on how to reduce the amount of cement water paste and the cost of the mixture. Number 1, allow the larger size of aggregate that can be accommodated in the pavement slab. Number 2, ascertain the aggregate is uniformly graded from coarse to fine. Number 3, avail of the biggest quantity of coarse aggregate consistent with proper workability. Number 4, adapt the lowest slump consistent with the proper pouring and finishing. So there is another way in testing the consistency of concrete is by the use of kale bowl method. So kale bowl method is a metal cylinder 15 centimeters diameter and 12 centimeters high with hemisphere bottom shape weighing 14 kilograms. A graduated handle rising from the top of the bowl is placed on the surface of the fresh concrete. Its penetration is measured by comparing its position with that of the frame. So the advantage of Kelly bowl method is that reading could be taken immediately on the concrete being poured on the roadway. On the contrary, the slump test requires more times but could be conducted in the selected samples. And that would be all from my topic, and thank you for listening. But for now, I will give the floor to Mr. Gilaga to discuss more about his topic.
Polymer concrete. Polymer concrete could be used alone or in combination with Portland cement to bind aggregates together producing concrete. There are three types of polymer mixture. Number 1 is polymer impregnated concrete or PIC. Is a Portland cement concrete impregnated with monomer after curing. And the number 2 is polymer concrete or PC. Is a mixture of polymer binder and aggregate. Number 3 is polymer cement concrete or PCC. It's a pre-mixture of cement paste and aggregate wherein a monomer is mixed before curing. Curing of concrete pavement. A newly placed concrete pavement needs curing. Curing may be accomplished by several methods. All methods could be categorized into two. The number one method is those that keep the surface constantly wet or cover it with water absorbent material that is rewetted time to time. The number two, those that pavement evaporated from the water already in the concrete which is retained is sufficient enough for hydration. Fine aggregates. Fine aggregates consist of natural sand, stone screening or other inert materials with similar characteristics. Fine aggregates, different sources of supply should not be mixed or stored in the same pile. Should not be contain more than 3 mass percent of material passing the 0.075 mm or number 200 sieve. The fine aggregate use of batch will not be allowed without the approval of the supervising engineer. If the fine aggregate is subjected to 5 cycles, weight loss should not exceed to 10 mass percent. Coarse aggregate. Coarse aggregate shall consist of crushed stone, gravel, blast furnace, and slag. Should not contain not more than 1 mass percent of material passing 0.075 mm or 200 sieve, or more than 0.25 mass percent of clay lumps, not more than 3.5 mass percent of soft fragments. Coarse aggregate slag density should not be less than 1,120 kg per cubic meter. Water also used in concrete mixing or curing. Water should be clean and free from oil, salt, acid, alkali, and grass. Joint fillers. Joint filler should be mixed asphalt and mineral or rubber filler. Storage of cement and aggregate should be waterproof with raised floor from the ground to protect from rain or dampness. Required qualification of workmen. There are two types of qualification of workmen. The concrete batcher, person performing the batching or mixing operation capable of accurately conducting aggregate surface moisture determination. Number two is a concrete technician. It's a person responsible for concrete production, controls, and sampling and testing for quality control, proficient in concrete. Concrete technician also need to be capable of conducting tests on concrete and concrete materials, capable of adjusting concrete mix designs, shall be qualified to act as the concrete batcher. The next is equipment. Equipment is necessary for handling materials and performing all phase of the work shall be approved by the supervising engineer as to design, capacity, and mechanical condition. Batching plant equipment is efficiently combines the various ingredients to mix up concrete, sand, aggregate, water, air, and cement. These ingredients are mixed at different ratios. Batching plant equipment should include bins, weighing hoppers, and scale for the fine aggregates. It also should be equipped with a suitable non-resellable batch counter. It should be equipped with automatic weighing devices. The next equipment is the mixers. Mixers at site of construction mixing should be done in an approved mixer capable of combining the aggregates, cement, and water. The truck mixers are used for mixing and hauling concrete. Truck agitators are used for hauling central mix concrete. Non-agitator trucks Our bodies of non-agitating hauling equipment for concrete shall be smooth. Next is paving and finishing equipment. Concrete should be placed and set with an approved paver designed to spread and consolidate. The concrete saw should be water-cooled diamond edge saw blade. Forms. Base of the form should be sufficient width to provide necessary stability in all directions. Form should be rigidly supported on bed during entire operation of placing and finishing the concrete. Setting of forms. The base support. Founder under the form should be hard and true to grade so that the form when set will be firmly in contact with its whole length at the specified grade. Grading and alignment. Form shall be set sufficiently advanced from the point where concrete is being placed.
So, good morning everyone. Let's proceed to the preparation of grade. So, after the base or subgrade have been placed and compacted to the required density, the areas that will support the paving machine and the grade on which the pavement is to be constructed should be trimmed to the proper elevation by means of a properly designed machine extending the work at least 60 centimeters beyond each edge of the proposed concrete pavement. So let's proceed to the setting of forms. So the first is base support. So base support is the foundation under the forms should be hard and true to grade so that the form when set will be firmly in contact with its whole length at a specified grade. And the second is grading and alignment. Form shall be set sufficiently advanced from the point where the concrete is being placed. And the third is grading and alignment. So the alignment and grade elevation of the form should be checked and corrections be made immediately before the placing of concrete. So the conditioning the subgrade or base course. So first, when the side forms have been securely set to grade, the base course should be brought to a proper cross section. And the second is, unless waterproof base course materials is specified, it should be uniformly moistened when the concrete is placed. So let's proceed to handling, measuring, and batching of material. So the batching plant and the equivalent layout must provide a smooth flow of continuous supply and transport of materials to the work. So in mixing in concrete, ready to mix concrete shall be mixed and delivered in accordance with ASTO M157 requirements. So the mixing time should not be less than 50 seconds nor more than 90 seconds. The volume of the concrete should not exceed mixer's nominal capacity. The batches shall be charged into the drum with a portion of the mixing water. The throat of the drum shall be kept free of concrete accumulation. Mixed concrete shall be transported in truck mixers. Retempering concrete by adding water shall not be permitted. So, limitation of mixing. No concrete should be mixed when natural light is insufficient. So, next is placing or depositing of concrete. Concrete is deposited in such a manner requiring minimal rehandling. So, placing of concrete between transverse joints without the use of intermediate bulkheads. Concrete is to be placed adjoining a previously constructed lane, and mechanical equipment operated upon the existing lane. Previously constructed lane must have attained the strength of 14-day concrete. Vibrators should not be allowed to come in contact with the joint assembly, grade or side form. Concrete should be deposited as near as possible to the expansion and contraction joints without disturbing them. So, concrete joint. are constructed according to the type, dimensions, and at their location as indicated on plans or special provisions. So concrete pavement joints are classified into longitudinal joint, transverse expansion joint, transverse construction joint. Load transfer device is provided along the longitudinal centerline of the pavement, either by the tongue and groove concrete or by steel dowels, but with considerations. So the next slide is final consolidation and finishing. So in this sequence of operations after placing the concrete at grade is the strike-off or consolidation, floating and removal of laytans, edging, and final surface finishing. So example ani kay finishing machine, hand finishing, floating, straight edge testing, and surface correction. Final finish, edging at forms and joints, and surface test.
Curing. Immediately after the finishing operation and the concrete has sufficiently set, the entire surface of the newly placed concrete is cured in accordance with either one of the following methods. First, the use of cotton or burlap mats. Cotton or burlap mats, the pavement surface is entirely covered with mat thoroughly saturated with water. The mat is placed and weighed to remain in intimate contact with the pavement and maintained fully wet in its position for 72 hours unless otherwise specified. Second, the use of waterproof paper. Waterproof paper, the top and sides of the pavement is covered entirely with waterproof paper. The units are lapped at least 45 centimeters placed and weighed down to remain in intimate contact with the surface cover. Joints are securely sewed or cemented together not to open up or separate during the curing period. The cover should be maintained in place for 72 hours after the concrete has been placed. The surface of the pavement is thoroughly wetted prior to the placing of the paper. Third is straw curing. Straw curing, when straw is used for curing. The pavement is cured initially with burlap or cotton mats until after the final set of concrete or in any case 12 hours after placing the concrete. As soon as the mat is removed, the surface and the sides of the pavement is thoroughly wetted and covered with at least 20 centimeters. Straw or hay measured after saturation of water to last for 72 hours. Fourth, by impervious membrane method. Impervious membrane method, the entire surface of the pavement is sprayed uniformly with white pigmented curing compound immediately after the finishing of the surface and before the setting of concrete has taken place. The curing compound is not applied during rainy days. The spraying equipment is equipped with a wind guard and time of use. The compound is thoroughly mixed with pigment uniformly dispersed throughout the vehicle. During the application, the compound is stirred continuously by an effective mechanical means. Hand spraying of odd width or shapes and concrete surface exposed by the removal of form will be permitted. The curing compound should have that property to harden within 30 minutes after application. Should the film be damaged from any cause within 72 hours curing period, the damaged portion shall be repaired immediately with additional compound. Fifth, the use of white polyethylene sheet. White polyethylene sheet, the top surface and side of the pavement is entirely covered with white polyethylene sheet. The unit are lapped to at least 45 centimeters, placing the sheet way down to remain in contact with the surface covered. The sheeting should extend beyond the edge of the slab at least twice the thickness of the pavement. The covering should be maintained in place for 72 hours after the concrete has been placed. Removal of forms. Forms for concrete pavement should remain in place undisturbed within 24 hours after pouring. The removal could be done as follows. First, crowbars are used in removing forms, pulling out nails and pins, but care should be exercised not to break the pavement edges. Second, in case a portion of the concrete slab is peeled off, it should be repaired immediately with fresh mortar with mixture of 1:2. Third, major honeycomb area will be considered as defective work to be removed and replaced. Protection of pavements. Concrete pavements and its appurtenances should be protected against public traffic and traffic caused by the workers. Protection of the pavement includes the posting of watchmen to direct traffic and the posting and maintenance of warning signs, lights, pavement bridges or crossovers, etc. Any damage to the pavement prior to the final acceptance of the work shall be repaired or replaced depending upon the extent of the damage. Concreting by the slip form method. If the contract calls for the construction for concrete pavements without using a fixed form, the following shall apply. The grade. After the grade or base have been placed and compacted to the required density, the areas to support the pavement machine is cut to proper elevation by means of properly designed machine. The base on where the pavement is to be constructed is brought up to the proper profile. If the density of the base is disturbed by the grading operation, it should be corrected by additional compaction before the pouring of concrete. The grade or base should be prepared sufficiently advanced for the concrete pouring. If any traffic is allowed to use the prepared grade, it shall be checked and corrected immediately before the placing of concrete. Next is placing of concrete. Concrete is deposited inside the form using the approved slip form paver designed to spread, consolidate, screed, and float finish the freshly placed concrete in one complete pass of the machine, in such a manner that minimum hand finish is obtained, yet provide a dense and homogeneous pavement in conformity with specifications. The machine vibrates the concrete full width and depth of the strip being placed. Vibration is accompanied by a vibrating tube or arms working in a concrete or with vibrating screed or pan operating on the surface of the concrete. The sliding forms are rigidly held together laterally to prevent it from spreading. The forms are trailing behind the paver, reticent that no appreciable slumping of the concrete will occur and the necessary final finishing can be accomplished while the concrete is still within the forms. Any edge slump of the pavements exclusive of edge rounding in excess of 6 mm is corrected before the concrete hardens. The concrete is held at a uniform consistency, having a slump not more than 40 mm. The slip form paver is operated nearly as possible to a continuous forward movement with all operation from mixing. Delivering and spreading concrete are well coordinated to provide uniform progress with stopping and starting of the paver held to minimum. If for any reason, it is necessary to stop the forward movement of the paver machine. The vibratory and thumping elements are also put to stop immediately. No tractive force is applied to the machine, except those that are also controlled by the machine. Next is protection against rain. To protect the concrete pavement against rain, the contractor is required to have available at all times materials for protection consisting of standard metal form or planks having normal thickness of not less than 50 mm and a nominal width of not less than the thickness of the pavements at its edge of the protection of pavement's edges, and covering materials such as burlap or cotton mats, curing paper and plastic sheeting materials for the protection of the pavements in case of rain. Acceptance of concrete. The strength level of concrete will be considered satisfactory if the average of all sets of 3 consecutive strength test result equal or exceed the specified strength Fc prime and no individual strength test result in deficient by more than 50% of the specified Fc prime. Concrete, which does not satisfy the above criteria, may be rejected unless the contractor could provide evidence, by means of a core test, that the quality of concrete represented by the failed test result in acceptance in place. At least 3 representative cores are taken from each member of concrete area in place that is considered deficient. Core location should be determined by the supervising engineer so that there will be least impairment of the strength of structure. The obtaining and testing of drilled cores shall be in accordance with AAS HTO T24 requirements. Concrete in the area represented by the core will be considered adequate if the average strength of the core is equal to at least 85% of Fc prime and if no single core is less than 75% of the specified strength. If the strength of controlled specimen does not meet the requirement and it is not feasible or not advisable to obtain core from the structure due to structural consideration, payments of concrete will be made at an adjusted price due to strength deficiency of concrete specimen are specified. Tolerance and pavement thickness. Thickness of the pavements will be determined by measuring the core from the complete pavements in accordance with AASHTO T148 requirements. First, the completed pavements will be accepted on a lot basis. A lot is considered 1,000 linear meters of pavement slab when a single traffic lane is poured, or 500 linear meters when the two lanes are poured concurrently. Second, the last unit in each slab constitutes a lot in itself when its length is at least 1.2 of the nominal lot length. Third, if the length of the last unit is shorter than one half of the nominal length, it should be included in the previous lot. Fourth, other areas like intersection, entrances, crossovers, ramp, etc. will be grouped together to form a lot. Each lot will be divided into 5 equal segments and one core will be obtained from each segment in accordance with AASHTO T24 requirements. Pavement thickness. It is the intent of this specification to set pavements into a uniform thickness as planned for the average of each lot as defined. 1. In calculating the average thickness of the pavement, individual measurement in excess of the specified thickness by more than 5 mm and measurement less than the specified thickness by more than 25 mm should not be included in the average thickness. 2. When the average thickness of the lot is deficient, the contract unit price will be adjusted to the thickness in accordance with the paragraph below, adjustment for thickness. 3. Individual area within the segment found to be deficient in thickness by more than 25 mm will be evaluated by the supervising engineer, and if in his judgment the deficient area warrant removal, it must be removed and replaced by the contractor at his expense. 4. When the measurement of any core is less than the specified thickness by more than 25 mm, the actual thickness for pavements in the area will be determined by taking additional cores at no less than 5 meters interval parallel to the center line in such direction from the affected location until a core is found in each direction which is not deficient in thickness by more than 25 mm. Methods of measurement. The area to be paid under this item is the area in square meter of concrete pavement placed and accepted in a completed pavement. The length is measured horizontally along the center line of each roadway or ramp. Curb and gutter will be included in the area of concrete pavement measured. Next is opening to traffic. The project engineer will decide when the pavement may be opened to traffic. The road will not be opened to traffic until after test specimens molded and cured in accordance with AASHTO T24 have attained the minimum strength requirements. If such tests are not conducted prior to the specified age of the concrete, the pavement will not be open to traffic until after 14 days from the time concrete has placed. Before opening to traffic, the pavement shall be cleaned and joint completely sealed. And that's the end of our reporting. I hope you learned something, and if you have any concern, feel free to ask. That would be all. Thank you.